Most people think they have a sense of how big the universe is. They don't. Not really. The numbers are too large. The distances are too long. The scale of what's actually out there is not something a human brain was built to understand. So tonight, let's try something different. Instead of throwing numbers at you, we are going to take a journey. You are going to leave Earth. You will pass the moon, the sun, the planets, the edge of the solar system, the nearest stars, the entire galaxy, the cluster our galaxy belongs to, the supercluster the cluster belongs to. And then keep going. And at every step, something strange will happen. The thing you just left behind will disappear until, eventually, even the parts of the universe you can still see are only a tiny fraction of what is actually there. You begin on Earth, a small, blue planet in a quiet part of a quiet system. The first thing to do is leave it. The very first stop on your journey is the moon, about 384,000 kilometers away. To put that in scale, a commercial jet flying non-stop would take about 18 days to reach it. Light, the fastest thing in the universe, takes a little more than a second. It feels close. By cosmic standards, it is. But even from this short distance, your home has already changed. From the moon, the Earth is a single fragile sphere. You can see entire oceans and entire continents at once. Whole weather systems, the thin blue glow of the atmosphere, barely thicker than a coat of paint compared to the size of the planet. It is humbling, and it is the closest you will ever feel to home for the rest of this trip. Now keep going. You pass through empty space until you reach the sun, about 150 million kilometers from Earth. We call that distance one astronomical unit. From here, light takes about 8 minutes and 20 seconds to reach Earth, which means whenever you look at the sun, you are looking at something that already happened, but you are still only at the heart of our solar system. Push outward, past Mars, past the asteroid belt, past Jupiter, past Saturn, past Uranus, past worlds we have spent entire missions studying. By the time you reach Neptune, the most distant true planet, you are roughly 4.5 billion kilometers from the sun. Sunlight takes more than 4 hours just to arrive there. And from Neptune, the sun isn't really the sun anymore. It is the brightest star in the sky, but just a star. And Earth, your home, your entire history, is no longer visible to the naked eye. You have only just begun. In 1990, a small spacecraft called Voyager 1 was about 6 billion kilometers from Earth, about 40 times farther than the Sun. At the suggestion of the astronomer Carl Sagan, the spacecraft turned its camera back one last time toward home, and it took a photograph. In that photograph, Earth was not a planet. It was a single pixel, a grain of pale blue light caught in a beam of scattered sunlight. Sagan called it the pale blue dot, and he reflected on what was visible in that one tiny point of light. Every person who had ever lived, every leader, every conflict, every name ever spoken, every story ever told, all of it, sitting on a pixel that was 6 billion kilometers out. And in the journey we are on tonight, we are not even close to leaving the solar system. Far past Neptune, far past Pluto, far past everything we usually call the solar system, lies the Oort Cloud, a vast spherical shell of icy debris, weakly held by the sun's gravity. Its outer edge is thought to extend nearly 1.5 to 2 light years from the sun, which means light, moving at 300,000 kilometers per second, takes up to 2 full years to cross from one side of our system to the other. That is the true edge of the sun's reach. Beyond it, the sun's gravity finally fades into the background. You have, at last, left our solar system behind. But there is almost nothing else around you. You are not nearly at the next star. You are just out in the dark. Now keep going. The nearest star system to ours is Alpha Centauri, 3 stars orbiting one another in a tight gravitational dance. It is 4.24 light-years away. That means light from those stars, even moving at the absolute speed limit of the universe, takes more than 4 years to reach Earth. To put that in perspective, if we sent Voyager 1, the fastest spacecraft we've ever launched, directly toward Alpha Centauri, it would take roughly 70,000 years to arrive. And from there, looking back, the Sun would not be the Sun. It would be just another star, indistinguishable from the others. The map of our entire civilization, viewed from this distance, is beginning to dissolve. Now, pull back farther, far enough to see our entire galaxy from above. The Milky Way is roughly 100,000 light-years across. It contains somewhere between 1 and 400 billion stars. Our Sun is one of them, a fairly ordinary yellow star, sitting about 2/3 of the way out from the galactic center, tucked inside one of the spiral arms. And here is one of the most quietly haunting facts in all of astronomy. Humans have been broadcasting radio waves into space for a little over 100 years. Those waves travel at the speed of light, which means every human signal we have ever transmitted, every broadcast, every transmission, every announcement, forms a sphere around Earth that is only about 200 light-years across, in a galaxy 100,000 light-years wide. If you scaled the Milky Way down to the size of a country, our entire transmitted civilization would be a single small town, glowing faintly in one quiet province. The rest of the galaxy, more than 99% of it, would have no way of knowing we exist. Now leave the Milky Way. We are part of a small cluster of galaxies called the Local Group. About 50 galaxies bound together by gravity, spread across roughly 10 million light-years. Our nearest large neighbor, Andromeda, is 2.5 million light-years away, which means the light from Andromeda that reaches Earth tonight left it before our species existed. But the Local Group itself is only a small region inside a much larger structure called the Virgo Supercluster. And the Virgo Supercluster, in turn, sits inside something even bigger, Laniakea. A supercluster so vast it contains roughly the mass of 100 million billion suns. The Milky Way, the Local Group, the Virgo Supercluster, all of it are just small components of Laniakea. And inside Laniakea, all of these galaxies are slowly drifting towards something we still do not fully understand. A region of unusually strong gravity called the Great Attractor. We are being pulled, we are not sure by what. Now, keep going for billions of light years until you reach the edge of what we can see. The observable universe is roughly 93 billion light years across. Not because the universe is 93 billion years old. It isn't. The universe is only about 13.8 billion years old. But space itself has been expanding the entire time. The most distant galaxies have been carried farther and farther away, even as their light traveled toward us. What you are looking at this edge, is the oldest light there is. The light from when the universe first cooled enough to become transparent, almost 14 billion years ago. And that is the edge of what we can see, but not the edge of what's there. This is the universe we can see. It is not the universe. Because beyond the edge of what is observable to us, the parts whose light has not yet had time to reach Earth, and whose light may never reach Earth, the universe almost certainly continues, possibly for an enormous distance, possibly forever. You are not at the center of anything. You are not even on a meaningful map. You are one person on one planet, around one star, in one arm of one galaxy, in one cluster, in one supercluster, inside what is almost certainly only a tiny lit corner of something larger than we will ever see. And we are only beginning to understand it.